Jai Hind to everyone. My name is Vikas, Assistant Professor in Department of Computer Science Engineering at Akgec Engineering College. Today, I'm going to discuss the topic is threads in Java is there. These are the contents of my presentation. What is thread is there, what is the life cycle of threads are there, method for creating threads, how you're going to synchronize the threads, choose an approach for the creating a threads are there, what are the threads priorities are. This is very important. On the basis of those priorities, those threads basically works are there. So, as Java is your multi-threaded language, which allows you to write any programs which have the more than one process can be executed concurrently within the single programs are there. So, Java threads are often referred as a lightweight threads are there, which means they run in the same memory space, but the different resources are being used, and parallelly they are being executed are there. So, because the Java threads is having the same memory space, they can easily communicate among themselves with the, because of the object is one thread can call the method of another threads are there. So, inter-thread communications can be happens. So, without and as they have the same memory space is there, they can communicate with each other. So, there won't be any kind of overhead for the operating systems in order to provide the communications between the these threads are there. So threads is basically is a lightweight sub process that run concurrently with other threads are there. Thread can be used to perform multiple tasks simultaneously, which can improve the performance and responsiveness of an applications are there. So, generally threads are being used when we have to run the process concurrently are there or parallelly are there, and the performance is one of the major tasks criteria for that applications are there. So, we use those threads are there. This is the basic life cycle of your threads are there. Threads are basically through which various stages through which it can pass through is 1, 2, 3, 4 and 5 threads, 5 stages through which any threads can be have to pass through, or you can say this is the life cycle of any threads are there. Whenever the any programs are being executed come to for compilations run there. So, first thing is a thread has to be created. So, every threads which is being created, so that must be moved first. Initially have to insert here at this state, that is newborn state is there. Once it is being received, it can move to the here in it move to the this runnable state here in this case. Okay. First start with the newborn, move to the runnable state. So, initially it moved to the this state, then it has to move to the this state. Okay. Now, once the state, the threads has reached to the runnable state is there. Now, they have to provide, the compiler has to provide the resources to there. Once the resource has been allocated, then it will move to the your running state here in this case. After that running state, there might be cases as the threads are being run parallelly are there. One thread is required the resources which is being held by the another threads are there. So, at that time these threads are being blocked in nature. So, they move to the block state here in this case. When another threads resource are being moved to the block state here. Now, if the resource is now available here, once the resource is being available, it again move back to the this state, that is runnable state here in this case. Then here in this runnable state, they already provide the resources, what kind of resources they needed. Now, that resource has been provided and it moved to the running state here again, here in this case are there. Once that process has been created, when the threads successfully execute those, whatever the task is there that has been done, now it moved to the this state here in this case, that is dead state here. Okay. So, what we do? We insert the, whenever the new thread is being created, it move to the newborn state. Now, from that it move to the runnable state, receive the resources, move to the running state is there. If all the resources are being provided and they successfully executed, it move to the dead state here, so that other threads can be used and they can have the resources are there. If threads are not successfully executed, they need further resources are there, then they move to the block state here in this case. At that block state, here another threads move to the running state in order to execute their threads are there. So, this is the process of the, we can say this is life cycles are there. Now, there are other things are being here in this case, we see is there. Let's take, if newborn is there, insert, move to the runnable, you say it is being started here in this case. Newborn directly move to the dead state. There might be any reasons. You have the high priority data is there, high priority threads are there. So, they are not providing the access, or they are not allowing the newborn threads move to the running states are there. So, after certain period of times, as they don't have the resources, they are not moving from newborn to the runnable states are there. So, they directly stop and move, they will destroy those threads are there. So, move to that state here in this case. Okay. So, again they move from newborn to the runnable state here in this case. Here again high priority is threads came again, they don't have the times, they don't have the resources, as the threads cannot be prolonged, acquire the memories are there. So, they have to see if for the specific particular times are those threads are being got the resources and they move to the running states or not. If not, so again it move to the stop state. Running, successfully executed, stop here in this case. Runnable, another thing is running here. During the running state, high priority threads came, this will yield back to the runnable state, say resources are there, but the high priority threads are being called, have reached. So, priority will be given to the high priority threads are there. I will discuss the later on what are the values that we give to the priority of the threads are there. Move back to the runnable states are there. We can also move from runnable to the block state, as well as from running to the block state here in this case. So, if your threads in the block state is there, there might be any kind of reasons are there, it will be waiting for the resources are there, they are not being provided, and another threads are being keeps coming there. Now, there is certain spaces there, they cannot accommodate the those threads which are not running. We not move to the running states are there, they move to the block state here in this case. They have to wait, or they have to suspend it, or they move to the sleep states are there. Okay. Now, if whenever the resources are being available, how they are going to say whether the data threads which are in block state needs to be moved back to the runnable states are there. For that, we use the notify all, notify is there. Once they threads are being notified that resources is being available, so it move back to the resume for move to the runnable states here in this case. So a threads when it is being created, it has to move or pass through the various stages are there, depending upon the resources, depending upon the priority, they are being executed. There are either they will be in a runnable state, they are being running state, they are being block state, or if they are being successfully executed, they move to the dead states are there. So newborn, when threads are being created, new state is being created, so move to the newborn state. Runnable state means thread is ready to run and awaiting for the control of the processor. Yeah, they are ready to run, but they don't have the resources. So they have to wait there for their turn in the queue here in this case. If the queue's resource is being provided, now they move to the running state. So running means the threads that control the process and code is currently being executed. Threads continue to in this state until it gets preempted. Another one comes in there and they are being kicked out by the high priority threads, or until it relinquished the control is there, or you can say they themselves executed all the processes there, their task is completed, they move to the dead state. Blocks is the state means that begins the prevent from the runnable to the running states are there. It is waiting for them to event in order for the re-enter to the scheduling queues are there. That is the thread when we finish the execution or being stopped by the another threads are there. So start, we already know we can start from newborn to the runnable start is there. Stop method is used for the stopping the threads immediately or abruptly way off the end of the threads are there. Suspended remains is moved to the block state, because so that they can be called back again and they move into running state are there. Resume when they are being used, threads is suspended, now they are being revived there and they will move back to the runnable states are there. Sleep method is being caused by runtime due to which put the current threads to the sleep for the n milliseconds are there. After n milliseconds they are spared, threads will become eligible for the run again are there. Yield is cause the runtime switch to context for the current threads to the next available runnable threads are there. This is the one way to ensure the threads at low priority do not get started here in this case. So how we are going to create it? There are two ways so we can create the threads are there. One is using the extending the threads are there, or we can implement the runnable interface are there. Here the threads is the already being defined in the Java is there. You just need to create a class which extend the thread class is there. So let's suppose you say let's suppose you are creating a class. My class extend the thread is there. So you define the class that extend the thread class. It can override the run methods which contain the code that you want to thread to be executed. So whatever the code that is being used in the threads, you can pass into your class and override there is a. You can create an instance of class and call it as a start method here in this case are there. If you are using as an interface, then you can implement the runnable interface here in this case. So here it defines the class that which implements the runnable interface. The run methods contain the codes that you want to execute. Create an instance of a runnable class, passes as the constructors of the threads to the objects. You can call the start methods on the thread objects are there. So this is the examples where we are creating a class my thread which extend the threads here, and they are using the overriding concepts which will call the methods which is being defined in the threads are there, and they are being called in this my thread, and they are being override those methods, and we can execute our methods within this class here. So we provide run system.mythread is being running here in this case. So now we have the public main class, public static void main string here. We are creating the two objects are there, thread 1 and thread 2 objects are being there. And this is the format is being there. My thread, thread 1, this is object which is being used, created with the help of the new keyword, new, and the constructor has been created with the no arguments here in this case are there. And whenever we have to display these values, we say thread dot start, we call it thread 2 dot start is there, then it will display these two values are there. So getting the two instance, two objects, and for those two objects we are running out threads are there. This is the example when we have to extend the thread classes. Another is when we have to implement the runnable interface are there. So we say class created my runnable implement and runnable here in this case. Now runnable class has been created already. You have to define the class runnable. Now you have to implement that runnable is there. Now whenever you are implementing it, you can use the override methods and you can create own methods in order to run it. Same way, just like in the previous examples, we created two threads here, thread 1 and thread 2 is there. And here we are providing the threads with the arguments here in this case. Previous examples, we are not providing the arguments, but here in this case, we are providing the arguments here. So it will call, whenever say this objects thread 1 is being created, so my runnable methods will be called, and which will override the runnable here in this case. The thread 1 will start with display the object of the thread 1, thread 2 start will display the thread 2 is there. So it will display the two results. My runables is running here in this case. So there are two ways through which we can create and threads are there. One is extending the threads, another is implementing the runnable interface are there. Now we have to make sure that as the threads are using the same memory space are there, now we have to perform the synchronization between these two threads are there. The various threads are there, as threads are parallelly executing are there. So we have to make sure that these multiple threads properly accessing the memory space, as well as the properly moving from runnable state to the running state here in this, in order to execute their task are there. So there are two ways we can synchronize those threads, by either by using the lock is there or using the synchronize method is there. Lock is an object which allow one threads to access the shared resources at a single instance of time is there. So to synchronize the access shared resources, you can use the lock to acquire a lock before accessing the resources are there. So in the life cycle, whenever the threads in runnable state, they need an resources there for whenever whatever XYZ resources they access, they have to provide a lock so that they can acquire those resources, and so that other cannot access those resources are there during their running state are there. When they move to the running state are there, once they are being successfully executed, they have to release those resources are there. Another method is synchronized methods. Synchronous method is method that only executed by the your one times at a time is there. So synchronized access to share resources, you can declare a method as a synchronized here. So there are different stages through which the synchronizers can happen. There are the various stages through which that threads get the resources are there. So if your resources threads have to wait for the certain period of time, let's suppose they have to move to the sleep state are there. So they have to say we sleep to simulate the time waiting is the thread dot sleep 15. So the thread have to sleep for the 15 milliseconds when it is being go for the sleep, when the thread is in runnable state are there, and they don't receive the resources are there, and for certain period of particular time they move from runnable state to the block state here this, so that the resources other threads can move from runnable to the running state here in this case. Okay, so for that we use the thread sleep 15 milliseconds. If we can perform the synchronizations for the block and the waiting state, we can say synchronize this, then they have to wait for the this type of milliseconds here in this case. Synchronous key is basically used to lock on the current instance of the thread lifecycle demo, which ensure that no other threads can enter the block and synchronize at the same time. So this wait 1000 cause the thread to wait for the 1000 milliseconds or until another threads called notify or notify all are there on the same objects are there. So during that time, whenever they are in block state, they have to wait there, and the thread release a lock of the objects and enters to the waiting state here in this case. Now question is which have to choose the approach we have to access is there, where which kind of say which method or which techniques or you can say approach we have to choose is there. As threads are being implemented, extending the threads or implementing as an interface are for the runnables are there. So at this point you might be wondering why the Java has a two way of creating the child threads, which approach is better here. So answer to these questions are there. Threads class defines several methods that can be oriented by the override, oriented by the drive class are there. Of these methods, only one that must be written is the run is there. So this, of course, the same methods requires when we implement the runnable is there. Many Java programs feel that the classes should be extended only when they are being enhanced or modified in some way is there. Or you can, so if you will not be overriding any threads, other methods possibly to best simplify to implement the runnables are there. So also by implementing runnables, your threads class no need to inherit the threads. It make it free of inherit different class. Ultimately, which approach is used is up to you. So either you can use the extend the if you want to inherit the thread class, then you have to use the extended threads class is there. If you don't want to inherit the class, methods are there, then you can use the runnables are. So it's entirely depends upon you which approach that you want to choose in order to implement the threads here in this case. Inter-thread communications. Another important point is here is inter-thread communications. As we take in the life cycles, when the your threads in the runnable state and they are or in the block states are there. During that, how they inter-thread process communicate with each other are there. As I already told you, that the threads having the same memory space are there, they can easily communicate with each other without any kind of overheads are there. So here in Java, whenever the threads are being created, we can use the wait, notify, and notify all methods are there. These methods helps implement final method objects, so the R class can have. There are three methods you can be called only from within the synchronized context is there. That is your wait, notify, and notify also. The wait tells the calling threads to be given to monitors and go to the sleep until threads enter the same monitors and call the notify or notify also are there. Notify will wake the threads and call for the wait to the same objects are there. Notify also wakes all the threads that called for the wait here in this case. So these methods are declared within the objects as shown. The final void way, or you can throw interrupt exceptions. Final, you can use it. Void notify, final notifies are there. Now, important point here in this, while the threads are being implemented in Java, is that what kind of priorities that you provide to those threads are there. There are three types of priority, the minimum priority, normal priority, and maximum priority are in this case. So by default, that there are 10 threads is there in the Java is there. So minimum priority is 1 with respect to the least priority is there. Normal for we have the 5 here. Normal priority is there, and the thread which is having the maximum priority is being the value is being 10 here in this case. You can change the priority of the threads by calling the set priority methods. However, important to note that thread scheduler is not guaranteed to schedule the threads in order to their priority. So public static int, minimum priority, normal priority, and maximum priority. So minimum priority value is your 1, is your 5, is your 10. So each threads in Java having their priorities, which determine order in which they are being scheduled, or you can say they are being get the resources and they are being executed there. So high priority threads will have the high priority for the executions are there. Inter-thread communications, you already know, shared and message passing is being as they are communicate with each other are there, and they share the same memory space are there. So inter-thread communications is, plays a vital roles whenever the two threads are being parallelly executing are there, and one thread needs an access for the other threads are there. So they can easily call those threads are there with the help of the message passing here in this case. So message passing techniques in which thread communicate with each other by sending and receiving the message. Messages are there. So these message passing is more reliable way of thread communication with the each others than sharing the variables are there. Why? Because while sharing the variables, during the synchronizations, your data may be corrupted there in this case. Thank you. So today we discussed the what is the threads are there, how the threads life cycle is being created are there, how the threads are being implemented are there, what how the threads are being communicated with each others are there, and all these things have been discussed. So very important point, the questions generally may be asked during the university exams. Define the life cycle of the threads are there, what are the stages through which these threads pass on there, and what are the various methods they are being used in order to move from one state to another states are there. So you have to be clear about all these things, so that will help in order to successfully clear exams are there. So this is the threads. Thank you.